Hey, hi all. So today welcome to my YouTube lecture on the direct and indirect band gap semiconductor. So this is one important terminologies that you guys need to be understand. So this is conduction band and this is valence band. So whenever the electron gains some energy and get into this state or it's given come back to this state, then what will happen is that the net change in energy will be released in the form of light. So this we already discussed there. So this will be light. So if it is the band gap, conduction band and valence band aligned in the same length, then the momentum will be conserved here. The side axis will be P or K. The momentum will be conserved and that is given in the form of photon, not phonon, it's photon, it's light. So in this case, that substance which are coming under direct band gap semiconductors, we can act in application of LED and other thing. One of the best example is the GAS, like germanium arsenic. So this is the structure which it will form is the zinc blend structure. Zinc blend structure. So because of this structural lattice only, it's acting as a direct band gap semiconductor. In this case of indirect band gap semiconductor like Si, Ge and these substances, these are example of indirect band gap semiconductors. These substances cannot be used for the application of LEDs and other things. So these have some other applications. So the structure that it will follow is the diamond lattice. So because of this diamond lattice structure, it's behaving as an indirect band gap semiconductors. So here what will happen is that whenever the electron jump from this state to this state, there is a transition in the momentum. The momentum is not conserved here. So then what will happen is that this kind of transition will be lost in the form of heat, not in the light. So here we can use this as a LED because this is a good application for LED, but this cannot be used because here the transition between the conduction band and valence band energy is released in the form of heat or phonon, not photon, it's phonon. So then this is not an real use application. Like this has some other application, but it cannot be used in the LED purpose. So the band gap, like this band gap structure is defining the momentum conservation, and based on the momentum conservation, we may use that as a light or we may use that as a photon or any other kind of application. So we know the formula that E is equal to mc square. So here the light is called as the photon. Light is photon. So we know that P1 which is equal to mc, we can define like this, and E1, E which is equal to P1C. So this is the standard definition. So P1 which will be equal to E divided by C. So this is what we are using here. So in this case of a phonon, what will happen is that E is equal to mv square we are defining. So this is nothing but phonon or heat. Okay. So the P2 which is here we mentioning as the mb, E which is equal to P2V. Then P2 which is equal to E by V. Here what will happen is that the net change in the P2 is much greater than the net change in the P1 in the direct band gap and comparing to indirect band gap. So what will happen, C is much greater than V, velocity and light. So P2 will be much greater than P1. So that's resembling here, and that is changed in the this quantity of heat. Like we can smallly define as the small momentum change, the small momentum change is associated with light. Whereas huge change is associated to heat. So that is what the huge difference here. So conservation of momentum will be leading to a light emission, and non-conservation of momentum will be leading into the heat emission, so that we cannot use for the LED and the other kind of light purposes. But it has some other purposes also. So in next class I will be letting you about the application like direct and indirect band semiconductor has. So here based on the conduction band and valence band we can come into this understanding. Here also you can see as per the last class definition, last class discussion on the effective mass of electrons and effective mass of proton, the curvature is less in the hole and curvature is more for the electrons. This is because of the effective mass of electrons is much greater than effective mass of proton or holes is much greater than the effective mass of electrons. So if you guys have any doubts, please ping in the comment section. Like, share and subscribe the channel. Thanks. Stay tuned for the next lectures.